Daniel, what's your paper about?
Yeah, hello everyone. So, as you said, thank you for introducing me. Daniel Peters is my name, and my paper is about IT security for measuring instruments. So, what we looked in the paper, what we're doing in general, let me start like this. So, I'm working for the PTB, which is actually in German the Physikalisch-Technische Bundesanstalt.
And what's that?
Yeah, let's say in English it's the Physical-Technical Institute of Germany that is looking into metrology. So it's not meteorology, which is actually weather and other stuff. We're metrology, so we're looking into measuring devices. Yeah.
Yep.
So in our department, in special, is looking into IT for measuring devices.
What kind of measuring devices?
So in general, what we are doing in our department is looking at legal metrology. Legal metrology is everything that you have to pay for afterwards, like electricity meters, gas meters, water meters that you have at home, traffic enforcement cameras if you're speeding, and other devices, taxameters if you take a cab. So everything that afterwards gives you a bill is also regulated by the state, and we have to look into these devices. So in our department, of course, there's another department that looks at the hardware, and we are looking in the software. Yeah.
What's your paper about?
So, and my paper is actually about the smart meters. So, new devices that are connected to the internet that are coming up in Germany and other countries. We already have them. So, it's the normal meters that actually look at the water and electricity and also gas consumption in the house. But these devices now also connected to the internet. It's not just a small device you normally had in your home. It's also a device that is connected to the internet. And here,
it's the smart part, right?
Yeah, it's a smart part. That's why we call it smart. And here, data is accumulated, and after that, it's sent to the provider to bill the consumer. And here, in our paper, we looked at the smart meters, and we wanted to construct an infrastructure which is based on blockchain to actually save measurement data, but also keep the measurement data private.
Okay. Why blockchain?
So blockchain because in our department, or also in PTB in general, we have a new project that is called the Metrology Cloud. And the Metrology Cloud is a digital quality infrastructure for legal metrology that connects many stakeholders, like manufacturers of devices, the notified bodies, which are really the notified bodies, is the authority that checks the devices before commissioning, before they go on the market. And then there's the market surveillance, which actually is looking at the devices in an interval of approximately 2 years in the market. So notified bodies, market surveillance, the manufacturer, and also the user at home that is using the devices and afterwards gets built. So these players all have to be connected like in a single point. This is why we constructed this Metrology Cloud to get into the digital world. Now, if you do that, normally everything is done by paper. So you send it to the authorities, they check the device normally by documentation, then they send it to the market surveillance to get the accordance. So it's a very bureaucratic way of doing it. More normally for paper, we would want to get everything digitalized. Yeah. Now, because we have so many players, and many players don't want to give their data, which is private perhaps, is intellectual property like manufactured to us, they want to have it on their own server. Then they have a server, we have a server, the market surveillance has a server, and here you can already say it's a distributed system. And distributed system, blockchain makes sense to have consensus between all the players with the servers, because our cloud is actually not just one cloud, just one single point, it's a distributed system with many servers. Yeah. And here blockchain comes into play. Because of that, and because another smart contract network we're developing right now that is more international, because the Metrology Cloud is just in Europe project. We also have a smart contract network, which is also the paper is based on, where we do like tests for smart contracts in general. Yeah? And one of this is like the smart meter case. Yeah.
Okay. And what's the conclusion of this case?
So in this case, the thing is that you actually want the data to go on the internet for the provider afterwards to bill the consumer, but the consumer doesn't want necessarily all this data to go public. So if you have something on a smart meter, we have privacy issues. And here we came to the conclusion that some things on the blockchain are easy to save. So it's like a database that is not erasable. But in that sense, we have to actually save the data encrypted on this blockchain, and then we have mechanisms like failure encryption to add these ones together. So what we're doing on the blockchain is actually working on encrypted data. Yeah. And
okay, so it sounds like a very practical solution.
Yes, it's a practical solution because failure, perhaps I can go more into the details of the technical stuff, like the failure encryption is a homomorphic encryption. And the homomorphic encryption means that you can actually work on encrypted data. So if you want to add, let's say, a simple case, 5 plus 3 together would be 8. So we have two numbers, 5, 3, and 8. But in the encrypted world, you can actually add an encrypted 5. So nobody sees the 5, just the encrypted result. The encrypted 3, nobody sees it. But if you add the two encrypted ones together in this
you can see
world,
the 8.
yeah, the 8 is coming out, but also encrypted. So this is what we're using in this failure system, that actually you can have many smart meters connected to one, what we call in Germany smart meter gateway. It's the thing where all the data is coming together. Then you can add them together without the smart meter gateway actually knowing the individual measurement of each smart meter, but in total knowing what was added together, so the total consumption. And this consumption can then be forwarded to the provider without revealing the individual data of the meter, yes.
Okay. You did this research on smart meters. Are there other applications as well?
Yes, so we started with smart meter. Next step, we have many applications in the sense of the metrology cloud, but one other aspect that is interesting, because PTP is normally looking into measuring devices, but we have some other domains that are also interesting and also done by us. One is gaming machines, so the slot machines that are checked by us, and another aspect is voting machines. So,
can you elaborate on that?
Yes, of course. So in my research group, we are like 8 people that also look into not the gaming machines, but more into the voting machines also in the next step. So we are planning to use, because also now we're doing a smart meter thing, with the privacy aspect, voting is also a very private thing. So you don't want, you want to actually vote, then afterwards perhaps add all your votes together, but you don't want to know what the individual actually voted for. So the anonymity has to be preserved. In this case, we have some servers around the world that we're using to actually check the smart meter contracts. We implement it also in this paper, but add some things like zero knowledge proofs and mixed nets to it. So what you want to do in the smart meter case, you still want to have the identity of the smart meter, but not really the result. So this should be encrypted from the individual smart meter. When you go into voting, you actually want to anonymize the voters themselves, so the voter names. And this is also an interesting aspect where you could use the smart meter and blockchain network, because with the blockchain you have like a system that makes it possible to store votes, but then afterwards these votes cannot be erased. And beforehand, if you encrypt them and mix them together rightly, nobody can actually see who voted for what. But at the end, you can add the overall result together. So yeah.
Which is supporting the voting.
Yeah.
Okay. Daniel, thank you so much. How do you find the conference thus far?
Well, it's very interesting, very nice. I also was at the blockchain talks this morning, so
yeah.
Perfect for me.
Right up your alley.
Yeah, right up my alley. So yeah, I'm really enjoying it. Thank you.
Okay. Are there any key takeaways for you at this moment?
At this moment, yes, that also what came out in the talks is that blockchain is disruptive technology, and it's at the beginning, but it's very, very promising in many domains, and it's also promising, of course, in legal metrology. Yeah.
Okay. Daniel, once again, thank you so much.
Thank you.